If you're watching this chapter the night before the exam, just turn it off now. You can't learn to speak math overnight.
It's going to be a times e to the r to the t.
Derivative is equal to 0 here.
And it's all over g of x squared, not g prime of x, right?
Math is different in that it's like a foreign language. I think it is a foreign language, the language of science. And so little doses of it many times are much more effective than one long marathon study session that one would have. When we have something in the denominator, what kind of exponent is showing up? What's the exponent we raise 10 to get 10 to the negative 3? The answer is, if you walk away from a math session, you're looking at the homework and you say, I think I understand. I think I need a little help with this. You do need help. Get right in there, go to that office hour, ask that question in class as soon as get to a tutor. As soon as any confusion hits, you take care of it, because you don't want to have all of these pile up the day before the exam.
These students are taking the prof's advice, seeing tutors well in advance of an upcoming midterm exam.
Numerator, g prime of x.
What do we know? Well, we now know our k.
They gave you the graph of your actual function, not the graph of the derivative.
Base case is true. It's always the easiest part, right?
The key is not just figuring out how to do the problems, but why. Listen in.
Got 1 equals e to the x. How would we solve for x? Natural log.
Why?
Well, the way that we bring down exponents.
After they talk it through, the student understands the why.
See? See what I'm saying?
Brilliant.
See? Brilliant.
Why is why so important? Consider this math class at Indiana University. Everyone here aced high school math, but on their first college exam,
we had as many F's as we had A's, about as many D's as we had B's.
The high grades went to those who understood the why of finding the right answer.
The students who do really well in my course on the first exam are students who were expected to do that in high school. But the others learn. They adjust. They learn that just understanding what you do is not the entire picture. They have to understand why you do it.
What does she mean by why? Think about it. Finding the right answer may require using multiple techniques. You have to know which techniques to use and what order to use them. You have to know which parts of the problem are applicable to the solution and which are extraneous. You'll be lost unless you know why you're doing what you're doing, says math prof Yiffy Pan of Indiana-Purdue University at Fort Wayne.
There's some mechanical part of math, but however, the understanding is the real issue of how well you're going to do in the test. You have to understand the concept, knowing what you're trying to do, instead of just mimicking the steps that you learned from book or from the class.
Think of it another way. When you want to go from point A to point B and you don't know how to get there, MapQuest figures it out and gives you turn-by-turn directions. With math problems, you have to be your own MapQuest and figure out every turn to make to get to your destination, the right answer. Allison Siegel tutors students who get lost.
Making sure that they know what equation to use with what set of numbers, and then also to know what numbers to plug into the equation. So they really need to know across the board how to do what the equations are and how to use numbers in those equations.
What is in it? What is at that energy level?
Success in science courses also depends on understanding not just how, but why.
To do well, to do really well in college level chemistry courses, you have to understand the underlying concepts. One of the most important things they can do is simply work the homework problems. If they can do those, then they're home free.
There is another challenge, however. As math strategies instructor Deuce McCune explains, in class and with your homework, you work on problems one concept at a time. On tests, however, you must sort through multiple problems and concepts, some of which you studied weeks or months ago.
I think one of the most difficult things students run into is maybe they can do the material when they're in a particular chapter that they're working on. But when it comes to a midterm or a final in a large math class, the problems are all jumbled up. I think this is the biggest problem that students run into.
Here's something you may think is a little odd. Success in math is as much about the words as it is about the numbers.
It's the greatest weakness of all students that I can tell in math. they find it very difficult to do word problems, partly because they're not in the habit of reading carefully and trying to understand what's in them. But they aren't used to just sketching little pictures and drawing diagrams. That's a very basic problem-solving skill that most of our students don't have. They're asking us for this situation, and I would definitely recommend that you draw a picture just to help yourself sort out what's being asked. And I'm assuming everybody can take it from there? It's always this easy once you got your picture.
Okay, the midterm is coming up. How should you get ready?
Okay, let's talk about how to study for a math exam. You should have completed all the homework. You should have completed the practice exam, and we're going to talk about a lot of the problems on that today. You need more practice on problems you've never seen before, because remember, you're not going to have seen any of the problems on your exam before.
Don't just plan to study, make a study plan.
Make yourself a very specific plan. Say, I'm going to work these problems, these problems, these problems. When it gets to be 11 o'clock or 12 o'clock, I'm going to go to bed. Okay? Sound reasonable?
Remember this about problem-solving exams. You have to understand why you're doing what you're doing. A major weakness of many students? Solving word problems. Here's a tip. Draw diagrams or sketch pictures to sort out what's being asked.